Hi, I'm Randall Heyman, a mathematics academic, and you're watching one of the videos in my playlist called Corona Help. So during the outbreak, if you'd like me to make a video for you or your students, your child, your grandchild, then comment below the video or send me an email and I'll try and help you out. Okay, so someone has written to me and pointed out that I've been a little bit vague, well, let's just say incorrect, in some of the way I've used these terms here: multiplicative, identity, element, unity, and units. So I thought I'd clear that up. It's going to be important in the next video that I do. Having said all of that, not all of these videos are abstract algebra. So if you've got any other questions that are not abstract algebra, I'm happy to have a look at them. In fact, someone's sent me another question, which I'll do that is from a different part of mathematics. Anyway, let's have a look at this. So multiplicative identity element. So I'll talk about rings, but it applies to integral domains as well. Let R be a ring. Then let's call it E, just to distinguish it from 1. Normally we say 1, but I'll just put E here. So this element E of R is the multiplicative identity element if E times R equals R times E for all R that are elements of the ring. So for all R that are elements of the ring. Now notice I put here the multiplicative identity element. You can only have one. It's unique. So you might want to have a go trying to prove that. That's an interesting little exercise. So example. So the obvious example is the ring of integers in Z. 1 is the multiplicative identity element. Since Z times 1 equals 1 times Z for all Z, little z that are integers. And here all I'm thinking is, think, 7, take an integer, 7 times 1 equals 1 times 7. And that applies. Well, I can change that 7 to any number. That's an integer and it'll still work. Okay, so a multiplicative identity unit element, sorry, is called unity. So we say sometimes a ring with unity. So that's just a ring that contains a multiplicative identity element. Okay, so that's the first two. Now we turn to units, and units are quite different. So I'll put a line here, and this is maybe where I've confused some people, maybe in past videos. So we'll let R be a ring again, but you can use it for integral domains. Let R be a ring. An element, let's call it F of R, is a unit if it divides unity. or we say, you could say, if we say, if it has an inverse, it being f, has a multiplicative inverse. You might see that sort of definition. So in Z, the integers, the only unit is 1, y, since we can multiply 1 by itself and we get 1. Now, let's look at another ring in, let's talk about, I'll write it out a bit more fully, Z. Let's do Z14. That's what Freilich's done, so I might as well do that. Plus multiplication, where addition and multiplication are modulo 14. So in other words, we're just looking at remainders here. This is, go back to my video modular arithmetic if you have trouble with this, but we're just dealing with the remainders when we divide by 14. So in this ring, then 3 is a unit, since 3 times 5. So I found another element of the ring, 5, and that equals 15. And 15 is equivalent to 1 modulo 14. So you might like to have a think of other elements in this ring that also are units. Okay, so that's all I wanted to say about multiplicative identity elements, unity and units. So I'll leave it there. Thanks very much. If you've got any questions on this, or you'd like me to do questions on some other area of mathematics, leave a comment below or drop me an email.